everyone, and welcome to the Micro e-learning program for the Global Parkinson's and Genetic Program and the Aligning Science Across Parkinson's. My name is Michaela James, and I'm a Data Science MPS Fellow at CARD. Today, I will talk about Illumina genotype clustering and visualization. We will be answering the following questions. What is a cluster plot, and what does it display? How do you view cluster plots using the GP2 Cohort Browser? Is it possible to create your own cluster plots for different SNPs of interest? And how do cluster plots relate to copy number variation identification? A cluster plot is a graphical representation of the distribution of sample genotypes within a SNP. It can be used to validate genotyping quality and batch consistency visually. For each SNP, 2 probes are synthesized to capture both alleles, here referred to as the A and B alleles, giving the 3 genotype options AA, AB, and BB. The fluorescent intensity of the probe binding to the sample target sequence indicates the strength of each allele. The genotype is then determined by a clustering algorithm applied to the intensities. To make the data more readable, it is then transformed into polar coordinates. In other words, instead of plotting the normalized A and B intensity of a sample, we will plot the R and theta values of that sample. The value R represents the distance from the center of the graph to the point, indicating the overall strength of the signals combined. The value theta represents the angle from a reference direction, usually the horizontal axis, to the point, showing the allelic ratio of the A and B signals. We can view cluster plots in 2 ways, through the GP2 Cohort Browser and through code that will plot the R and theta values. The first method you can use to view cluster plots is through the GP2 Cohort Browser. To access this site, you must be signed in with the same Google account used for GP2 Tier 2. We will then navigate to the SNP metrics section where you will have the option to change ancestry, chromosome, and SNPs of interest. For this example, I will use chromosome 12 with European ancestry data, and I will search for the SNP RS222-39062. From there, we will see the cluster plot and several additional metrics such as the GenTrain score, the minor allele frequency, and the genotype distribution for cases and controls. The cluster plot is color-coded by the genotype and distinguishes between cases and controls. As stated earlier, theta is a polar transformation for allelic intensity, and R is the sum of the A and B allele. The GenTrain score is a metric used in Illumina genotyping to assess the reliability and accuracy of a SNP genotype call. There are instances where you want to customize a plot or generate many cluster plots at once. For those instances, you can create cluster plots in Python. The code behind the cohort browser can be found here. You can copy the function plot cluster into your own Jupyter notebook. An example of customizing cluster plots can be found here. Please note that due to space limitations, the SNP metric data is not available in the GP2 bucket. However, it can be made available upon request. Using the data from the cluster plots, we can calculate 2 key metrics to help identify copy number variance: the B allele frequency, BAF, and the log R ratio. The BAF is based on the theta value of the sample compared to its expected theta values, which is 0 for AA, 0.5 for AB, and 1 for BB. The log R ratio is the log 2 of the ratio between the observed and expected R values. In both cases, an increased signal intensity indicates duplications or amplifications, and decreased signal intensity indicates deletions, as seen in the example graph where Cn equals copy number. In summary, cluster plots are a useful tool for quality control and copy number variation detection. You can view these plots through the GP2 Cohort Browser or by creating the plots in your Jupyter notebook. Thank you for listening, and I hope you enjoyed the module.